Hello, so welcome back to IGCSE Chemistry. What we're going to be doing is we're going to be continuing from the last two videos where we're looking at periodic table and specifically we were looking at periodic trends. So it's trends in the periodic table. So this video we're going to focus only on group 1, but we got to first revise what we were doing in the last video. So in the last video we had looked at the periodic table. And we had seen that it was divided into rows and columns. And the rows, which is horizontal, so this is from left to right, we called these periods. And what we had seen is that basically, atomic mass increases from left to right. The valence electrons increase from left to right. And we also saw that there was some small trend in melting and boiling point. We had seen that melting point increases up to group 4, and there was a sharp decrease in nonmetals before it decreases all the way down to noble gases. So we'd seen some sort of trend like that. And the last one that we had seen was that on the left-hand side of the periodic table, we had metals, and it eventually transitions to nonmetals on the right-hand side of the periodic table. And then we had columns on the periodic table, and we called these groups. What we found out with the groups is that they have similar chemical reactivity. So we can also call them kind of like a family, groups and families. They're a family of elements. So they have similar chemical reactivity, and this was due to the same number of valence electrons. So those are what we've seen so far. And in these columns, what we saw for group 1, this is revision, and for group 7, so group 1 and group 7, we saw that reactivity increased from top to bottom. And then this one was that reactivity decreased from top to bottom. So we saw that there were some differences, right? These are the opposite of one another. So if you remember one of them, it'll make sense to kind of remember the second one. You say, okay, group 1 reactivity increases from top to bottom. So lithium is less reactive than sodium, which is less reactive than potassium. If we look at the right-hand side of the periodic table, we've got fluorine, chlorine, and iodine. And reactivity increases all the way to the top of fluorine, which is the most reactive. So in this video, basically all we're going to cover is different trends in group 1 properties. So let's talk first about melting points and boiling points. Melting points and boiling points, MP and BP. So what actually happens with melting points and boiling points is, if you can imagine, right, we've got these metals. And if we look at a lattice structure, so we've got these metals in a lattice structure. And what we see is that, right, we've got, I'll change the color for the electrons right here in red. Metallic bonding, what it is, right, we've got the positively charged nucleus and these negatively charged electrons. And what actually occurs is that, metals are conductive. So these electrons, like we say, they're free to move. They're in a delocalized sea of electrons. These electrons are constantly moving around and hopping to their neighbors and basically floating around all of the atoms in this lattice. But what dictates the strength of the metals, the strength of the metallic bond, is how much this electron right here how much this electron right here can feel the attraction to his neighboring nucleus. So if you can imagine, you've got, small ones put together, or that's a bad example. Let's say you've got, an atom with 2 rings versus an atom with 3 rings, 3 electron shells versus 2 electron shells. If you look at this drawing, right, this electron here can probably still feel the nucleus of his neighbor. But if we look at the next one, right, as the electron shells get bigger and bigger and bigger, these electrons on the outside, these valence electrons, feel less and less and less of a pull towards the neighboring nucleus. So what occurs is that actually the strength of the metallic bond decreases down group 1. So they've got weaker and weaker and weaker metallic bonding. And as we all know, right, bonding is what keeps elements together. So if we've got weaker metallic bonding, this will be the first trend that we have to talk about in the video, is that melting point and boiling point decrease down group 1. So it actually decreases down group 1 because the strength of the metallic bond gets weaker and weaker and weaker. So lithium would have a stronger metallic bond than sodium, which has a stronger metallic bond than potassium, stronger metallic bond than rubidium. And this is, in case you're taking notes, this is metallic bond strength. So that is why the melting point and the boiling point decreases. It's because the ability of this electron to move around very, very quickly is the fact that he needs to be attracted to the nucleus of his neighboring atom. If he's not attracted to the nucleus of his neighboring atom, he doesn't move as much, and in that case, the strength will decrease down the group. So let's move down to the second trend that we have. So that's melting point and boiling point. The second trend that we have to learn about is density. And this is a trend that I'm not necessarily a fan of. To write density, the symbol for density is like this. And density, we'll first talk about what the trend is, and then we'll talk about why it is afterwards. The trend is that density tends to increase down group 1. So density tends. This means that it's not always true. Not always true. So it's not always true that density increases down a group, but for group 1, it's somewhat true. If we were to look at the density of lithium versus sodium versus potassium and rubidium and cesium, we would see that the density of lithium is 0.53 grams per centimeter cubed. Then we'd have 0.97 grams per centimeter cubed. Potassium would be 0.86, rubidium 1.53, and finally cesium is 1.88. So why this density increases down, why I don't necessarily like, this trend particularly. It's because there are exceptions, right? We see 5.39786. We see that this is less dense. Grams per centimeter cubed is the unit, so it's grams per volume. This one has a lower grams per volume, but sodium is breaking the trend in this case. So why density increases down the group? We can talk about this. So let's look at, let's look at a few atoms. So let's look at the mass of them. So lithium is 6.94. Sodium is 22.99. Potassium is 39 and then 85. 39, 85. I'm just going to do the first two numbers just so we can work through this. And 132. So our rules still apply here, but we have to know that it depends on several factors. Depends on several factors. And these factors that it depends on is, right, if we're taking these atoms, let's just say we take lithium atoms and put them together. We know that inside lithium, there are going to be 3 protons and 4 neutrons. So we've got, what the mass is of the nucleus. This is the mass of the nucleus. And we've got these electrons that are floating around the outside. Lithium has a 2-1 structure. But we know that, when we jam all these lithiums together, we're increasing the metallic bonding. So, this electron wants to pull this lithium center closer to this neighboring lithium. But at the same point, right, these core electrons are interacting with these core electrons, and they're repelling. So in this case, we've got multiple things happening. We're having the valence electrons pulling towards its neighbor. We have all of the electrons pushing against each other. But also we've got, this is how many not grams necessarily. This is how many AMU, atomic mass units, are held within the core. So as we get bigger, right, if we moved all the way to lithium, sodium, potassium, rubidium, and cesium, we move all the way to rubidium, right? We've got, a large amount of layers. So let's try to draw this out properly. It's got 2, 8, 8. Let's see, it's got 2, 8, 8, 8, 1. 2, 8, 8, 8. And it's got another layer on here too. 1. So if we were to look at these rubidiums next to one another, right, these core electrons, these electrons here, are going to really push away from neighboring ones. And when it pushes away, it decreases the density. However, if we look at how this mass is increasing, right, it's not increasing linearly. It's not going 7, 14, 21, 28. So the mass isn't increasing in a linear fashion. The amount of protons and the neutrons in the core are increasing a lot faster, right? 7 to 20, this is a 3 times increase. And this is a smaller increase, right? This looks like it's a 1.5 times increase. Then here we've got what looks to be like a 2 point sometimes increase. And here about another 1.5 times increase. So we see it's not increasing in a linear fashion. So this nucleus is getting heavier and heavier and heavier, even though these electrons are pushing away from each other, and the valence electron of its neighbor is not that attracted to the core and pulling them together. Still, the mass is taking precedence here. It's the strongest one, or it's the one that's determining more for grams per volume. So it's the one that's taking precedence here. The gram increase is more important than the volume increase in this case. So it results in a larger density. So our trends that we've covered so far is that for group 1, that reactivity increases down. We talked that density, remember this sign, increases down. And we say melting point and boiling point decreases going down. And hopefully this makes why it decreases, right? Melting point and boiling point depends on how well this valence electron is attracted to the core of its neighbor. In rubidium, right, he cannot feel this positive core, because to feel the positive core, he needs to work through 2 electrons here, 8 here, 8 here, 8 here. He needs to work through a lot of negative charges just to feel some attraction to the neighboring atom. And the last thing that I want to talk about, we already talked about reactivity. Let's talk about reactivity with water. So reactivity with water. So what we see, when we get back to school, we can start doing these experiments again. We'll see the reaction of lithium, sodium metal, and potassium with water. What you'll see with lithium is you're going to see some slow movement, a little fizzing, but it's not going to be anything spectacular. For sodium, we're going to see fast movement and more fizzing. And actually with potassium, what's really, really cool we see is if we've got, a container of water and we put a bead of potassium on top, what actually occurs is it lights on fire because the reaction, it's so reactive, so reactive that the energy, right, we release hydrogen gas for these reactions, and the energy is enough to actually ignite the hydrogen gas and let off this beautiful purple flame, just like the flame test for potassium. So since reactivity increases, the reactivity with water increases. And the last thing that I want to cover is that when group 1 metals react with water, group 1 metals reaction with water, it forms an alkaline solution. And we got to cover why it forms an alkaline solution. So actually what occurs, this is the unit that almost everybody hates. It's a redox reaction. It's a reduction oxidation reaction. So if let's look at the equation first and let's analyze it. But the first one, the most important thing to remember here is group 1 metals are called alkali metals. So if they're called alkali metals, we can imagine the solution is going to be alkaline after the reaction. So let's look at this. Let's pretend like we're reacting potassium with water. And we know that it's going to form an alkaline solution, so it should most likely form a hydroxide, so potassium hydroxide, and H2 gas. So we got to balance this. This looks a little bit off. So we got a top, a 2 here, a 2 here, a 2 here, and then it looks like we're pretty balanced. I'm just putting in the state symbols here really quickly. So we form, a different product. So let's analyze what's getting oxidized and what's getting reduced. Here we've got K in a 0 oxidation state, and here we've got K plus, because remember OH always has a -1 charge. So we've gone from a 0 state to a +1 state, so it has oxidized. And this H2O, right, if we were to draw an H2O molecule, remember that oxygen is electronegative, so it loves electrons, so it's pulling on these bonds. These bonds are, they're not equally shared. They're sharing electrons, but not equally. So this hydrogen, we say he has a small positive charge. So hydrogen before has a positive charge, and then now we've got the element. And as we all know, the element has a charge of 0, so it went from a positive charge to a 0 charge, so it is reduced. But if this doesn't make sense to you, of course, we need to revise the electrolysis unit a little bit. But the important thing to remember here is that group 1 metals are alkaline in solution, and they produce the metal hydroxide when reacted with water. Okay, thank you. I will see you in the next video where we will see group 7. Thank you.